Welcome to Two Projects. In this video, we are going to explain the project Image Classification using SVM and CNN. Before diving into the execution, let me give you an overview of the project. So, image classification, the task of sorting images into predefined categories, is very important across various fields. It is needed to automate the analysis of large image datasets, enhancing efficiency and accuracy. So the project focuses on classifying images into five different categories in this project that are sunflower, soccer ball, Dalmatian, pizza, and dollar bills. Traditional methods of doing this, that is, classifying images, often struggle with complex patterns and variations. So, to overcome this, the project proposes to use SVMs, that is support vector machines, and CNNs, that is convolutional neural networks, which are known for their ability to handle high dimensional data and learn hierarchical representations directly from pixel data. And the workflow involves importing image data of five different classes, exploring its characteristics through visualization, pre-processing the images to convert them into suitable format, and splitting the dataset into training and testing sets, where train set is for training the models and test set is for evaluating the model's performance. And different models, including SVM, CNN, and combinations of both, that is, combining CNN and SVM, and also exception, are trained and compared based on performance metrics like accuracy, precision, recall, and F1 score to select the best performing model among them. So, this is what happens in this project. And the overall objective of the project is to develop a reliable image classification system applicable across industries, saving time and effort in analyzing visual data and aiding decision making processes. So, this project benefits researchers, developers, and practitioners in fields like image processing, computer vision, and machine learning by providing a robust solution for automating image categorization tasks. Now we'll look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework required is Flask, backend framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So first we have proposed to use SVM, CNN, and the hybrid model combining SVM with CNN, where the features extracted by CNN are fed into the SVM model. So these were the models built first. For improved performance, we have extended the project by employing exception model. We have built all these models. We have compared their performance using accuracy, precision, recall, and F1 scores. And we have observed that the extension exception model has outperformed all other models in all the performance metrics. So we have deployed the exception model into the Flask framework. We will be executing the project using Flask web application. Before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is dataset folder in which I have 5 folders. So these are 5 different classes I have. So in these folders, I have the respective images. So in Dalmatian folder, I have these Dalmatian dog images. Similarly, in dollar bills folder, I have dollar bills images. In pizza folder, I have pizza images. Similarly, I have respective images in other folders also. So we will be training the models on these images. So before training the models on these images, we will split these images into train and validation sets. Train set is for training the models and validation set is for evaluating the model's performance. So after doing that, after splitting the data set into train and validation sets, we have stored the train and validation sets in this output folder. So I have five folders, five subfolders here again. So 80% of the data has been stored in this train set and remaining 20% of the images are stored in the validation folder. This is sample folder in which I have sample images that are test cases. This is static folder which consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. So this .py file contains the information related to front-end logic. It includes coded in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model folder which contains model files, and these are also model files. So these files contain algorithm information. So these files will be loaded into the project code during runtime to utilize the train models. This is Notebook Jupyter source file, which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So it stores information like user signup details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path, I'm copying it. Open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a login link, click on it. So if we already have an account, we can directly log in by giving our credentials, username and password and clicking on the login link. And if we are new to the system, we have to register ourselves first. Click on the sign up link here, fill in all these details and click on register button to sign up first. So as I'm already a member, I'm clicking on sign in link. I'm giving my credentials here. So give the credentials and click on login button. So it has redirected us to the classification page. So now we have to upload images here to see the classifications made by the application. Click on choose file. So from sample images folder, these are the test cases I have. Select any image. I'm selecting the first image and click on open. The image has been loaded. Now click on submit button. So we can see the application has classified the uploaded image as dollar bills. Here we can see the result, that is dollar bills detected. So we can see the correct classification. Click on back, click on choose file. This time we'll try with this image. We can see the application has classified the uploaded image as pizza. So the application has correctly classified the image as pizza. We can see pizza detected here. Click on back, click on choose file. This time we'll try with Dalmatian. Select the image, click on open, click on submit button. So we can see the application has detected the Dalmatian dog. We can see the correct classification here. Click on back, click on choose file. We'll try with this one. So we can see the application has identified the soccer ball from the image. It has classified the uploaded image as soccer ball. So in this way, we can upload any image and can get the classifications. Click on choose file, select the image from the test cases. I'm selecting this image. Click on open and click on submit button. So we can see sunflower detected here. So the application has correctly classified the uploaded image as sunflower. We'll try with one last image. Click on choose file. I'm uploading this image. Click on submit. We can see sunflower detected. Click on back. So we can also take images downloaded from Google. We'll try that. I'm searching for soccer ball images. So these are the results. We'll try uploading this image. Download the image first. Click on choose file. Select the downloaded image and click on open. The image has been loaded. Now click on submit button. So here we can see the result, that is soccer ball detected. The application has correctly classified the object in the uploaded image as soccer ball. We'll try again uploading another image. We'll try with this image this time. Download the image. Click on choose file. Select the downloaded image and click on open and click on submit. So we can see the correct classification here. The result is soccer ball. This time we'll try with sunflower images. So we'll try with this image. Download the image. Click on choose file. Select the downloaded image and click on open. The image has been loaded. Now click on submit button. So here we can see the correct classification, that is sunflower. The application has correctly classified the object in the image as sunflower. We'll try with one more image. We'll try with this one. Download the image. That is not in suitable format. We'll try with this image. Download the image. Click on choose file. Select the downloaded image and click on open. The image has been loaded. Now click on submit button. So here we can see the correct classification, that is sunflower detected. We'll try with pizza images this time. We'll upload this image. Download the image. Click on choose file, select the downloaded image and click on open. The image has been loaded. Now click on submit button. So here we can see the correct classification, that is pizza. The application has correctly classified the uploaded image as pizza. So in this way we can also take images from Google and can get the classifications. Now we'll look at the graphs plotted. Here we can see a graph link, click on it. So here we can view all the visualizations made after performing different pre-processing steps like converting the color spaces and normalizing the images. So these are the sample images. These are different classes I have, and this is histogram of pixel intensity of this image. These are CNN performance graphs. This is accuracy graph, this is precision graph, this is recall graph, and this is F1 score graph. Here blue line represents the performance of the train set and orange line represents the performance of validation set. Similarly, these are the exception performance graphs. And these are comparison graph. This is the comparison graph of all the models. Here blue line is the accuracy, orange color bar is the recall, green color bar represents precision, and red color bar represents F1 score. We can see SVM has secured least scores. And these are individual graphs. This is accuracy scores comparison graph. This is precision scores comparison graph. This is recall scores comparison graph, and this is F1 scores comparison graph. We can say exception model is doing well. Now click on sign out. So these are the graphs. So in this project, we have developed and compared SVM, CNN, combination of SVM and CNN, and the extension exception models for classifying images into 5 categories. The exception model outperformed others, providing a robust image classification system that benefits researchers, developers, and practitioners by automating categorization and enhancing decision making.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.